Imagine hiring a brilliant CEO, but locking them in a windowless boardroom with no phone and no internet. When you ask them for a report on this morning's market volatility, they have no choice but to guess. This is why standard AI often makes things up. It is fundamentally disconnected from any information that happened after its training ended. Modern AI architecture solves this by using a multi-agent system, a group of specialized digital workers collaborating on a single task. In this setup, different agents handle planning, logic, and data gathering. The linchpin of this team is the retriever agent. Think of it as a dedicated research analyst who works alongside the thinkers. While the rest of the system handles the logic, the retriever focuses entirely on finding the evidence. It has one specific mission: to plunge into massive external archives, sift through millions of files, and bring back the exact raw data required to answer a specific question. Intelligence requires context to be useful. An AI system knows nothing about the world today until the retriever agent identifies and delivers the necessary facts. We can see this in action with a financial query. A user asks, "Why is the Nifty stock index falling today?" This animated diagram illustrates how the retriever uses vector embeddings. It translates the user's words into a mathematical concept map. Instead of looking for the exact letters in the word fall, the retriever locates the neighborhood of the idea, pulling in related data points like bearish trends and selling pressure. Once the neighborhood is identified, the retriever performs a top K search. The K represents a limit set by the designers. In this case, the agent scans the database and selects the 5 documents that sit closest to the user's query on that 3D map. These 5 folders contain the specific signals needed: U.S. inflation data, a bearish trend on the 50-day average, high institutional selling, and rising oil prices. The retriever hands these specific findings to the reasoning agent. With these facts on the table, the reasoner can finally explain the market movement accurately. The AI didn't predict the drop through intuition. The retriever agent taught the system exactly what was happening in less than a second. Now, consider an IT emergency. A developer reports that their Oracle database is stalling during end-of-day processing and needs an immediate fix. The challenge here is the sheer volume of data. An enterprise archive might hold 20 years of logs and tickets. If the retriever looks at everything, it risks bringing back outdated or irrelevant information that would lead the AI to the wrong conclusion. To maintain accuracy, the retriever uses metadata filtering. This allows the agent to set hard boundaries, automatically ignoring any file that doesn't meet specific criteria before the search even begins. The retriever locks the search down. It instructs the database to only show files labeled as system logs, created within the last 24 hours. The millions of potential files vanish, leaving a few precise logs, showing high input-output wait times and missing indexes. The IT crisis is identified instantly. In a multi-agent system, the quality of the final answer depends on the retriever's ability to isolate the signal from the noise. Designing a retriever agent requires constant balancing. Engineers have to make specific choices about how thorough or how fast the agent should be. This seesaw diagram shows the trade-off between recall and latency. If you ask the retriever to fetch 50 documents instead of 5, you increase the chances of finding the right answer. But processing that much data drastically increases the time it takes for the user to get a response. There is also hybrid search. Sometimes the system needs to find broad concepts and specific text simultaneously, like a unique error code, ORA00054. Hybrid search combines mathematical concept mapping with traditional keyword matching. As the matrix shows, this approach moves the system into the high accuracy zone. However, running 2 types of searches at once causes the technical complexity and the operational cost to spike. These engineering decisions are the foundation of the system. If the retrieval is poorly managed, even the most advanced logic engine will fail to produce a helpful answer. A precise AI response is the direct result of a retriever agent working tirelessly behind the scenes. Ultimately, the retriever defines the boundaries of what the AI is capable of knowing.